I'm just going to spend the next few minutes going over my, I hesitate to say, latest effort. It's been going on for about 4.5 years now. I've only done 2 prior games. The first one was simply to get acquainted with 6502. That was the Snake game. Then the biplane game got a bit more advanced, and then my latest effort, I got a bit, well, quite a lot more ambitious. So I'm just going to share my screen, hopefully, just to give you so you can see what it is. Most people probably have seen the infamous yellow screen, but for those that haven't, I shall select that now, and there we go. So blank yellow screen, more or less, but I'll just quickly show you this little worm game I've got going. It looks a little jerky because that was over Zoom and my laptop's struggling to do it all. But this is a kind of continuous runner game where the objective is essentially to pick up objects and avoid others and so on. It's not yet complete, which is the ongoing story of this game, but hopefully I'll be explaining why shortly. So that's a quick view of the game. I'm now going to switch to a slide deck that I rustled up at some point earlier. So and that's basically what I'm going to go quickly whiz through. So to begin with, the origins of the game idea. Basically, my other half fancied herself as a bit of a games designer. She's a keen console games player, and she thought I should have a go at trying to write a game for mobile phones. And basically, I started looking into all this, and she came up with the game idea of the continuous runner. Obviously, that not being truly original, but with a sort of humorous worm character, and also for it to be in 3D and everything. It was very fully featured and very easy to spec when you don't have to program it. Anyway, I looked into there's various engines that you can do for modern for coding on modern platforms. Indeed, I looked at them, including one that's I think still very popular today called Unity. But quite honestly, I was a bit put off by the sheer scale of these sort of game engine stroke frameworks, and I kind of didn't like Unity. Looked to be the most appropriate to do mobile at the time, but I didn't like its the way it seemed more focused on almost a graphic design perspective rather than being more programmer centric. There's since been an open source product called it's either pronounced Godot or Godot, and I'm quite interested in that, and I think I'll be looking to try that out if I ever get this game finished. So that's the origins of the game idea. So what I'd like to do is just give you a quick tour of some of the more difficult problems that I've had to solve. And as you can see, those are scrolling, doing a level editor, and collision detection, and an energy bar. So so if I start to talk about scrolling, broadly there's 2 ways you can think about doing scrolling. You can either do it in software or hardware. So software scrolling is where you effectively had to redraw either all or part of the screen, usually part of the screen, because early 8-bit machines didn't have the power to update the entire screen per frame, 50 frames a second. And then the hardware scrolling, where you get to basically change the offset at which the screen memory starts to display on screen. Both have their trade-offs, and what I could do is very quickly show you those trade-offs now, or attempt to, if I press the right buttons. So okay, So a very famous early game that we'll try and load up. Okay, and why hasn't that loaded? That's interesting. Let's try that again. Play. Better. Okay, so this is a hardware scroll again. This is a very early example, I think about, yes, 1982. And so hardware scrolling is kind of good because you get some hardware help. But the trade-off, it's a lot smoother than you're seeing here. But the trade-off, I'll stop that now. The trade-off is that the scrolling is whizzing by really quickly, and I'll go into why in a second. With software scrolling, well, you kind of get to make your own rules, and this is a similar game, based off the same arcade game by our resident expert games programmer Tricky. And if we were to look at scrolling on here, if I can press the right keys to get it to go. So here, this is all being done in software. So parts of the screen are being redrawn each frame. And it not only is it incredibly smooth, but also it's incredibly smooth. And what the hell else was I going to say about it? Oh yes, it's it's scrolling by an awful lot slower. It's scrolling per pixel across the screen, and that's kind of important for a game where you want to be able to collect objects or avoid objects. If everything's whizzing by too quickly, then well, that's not going to be a fun game to play. So I looked at what options I had with the coding skills I had, and I was kind of attracted to hardware scrolling. So here's a quick explanation of hardware scrolling. So what I've got in front of me here is like a sort of cut down example of what screen memory might look like. So the beauty of hardware scrolling, or the attraction to it from a programmer's point of view, is that if you're scrolling from if you're scrolling across the screen from the right hand side of the screen to the left, all you got to do every frame is paint the far right column, and then you scroll the screen, and then you just paint the far right column again, so you don't have to update the entire screen. So that sort of attracted me. So I had a go at that, but it has its trade-offs. So as we scroll through, if you look at the memory address numbers of the screen, the top left is with just saying it's memory address 0. In reality, it would be whatever offset we have in BBC memory for the screen mode you're in. But for the sake of the example, so first frame, all nicely ordered from the top left to the bottom right, row by row. We then go to the next frame, and now we've shifted the screen memory to start from the next character address along, which is 8. So now naught is down here, and if we compare this far right column to the first screen we just looked at, everything's moved on by 1, except that instead of not being at the top, it's at the bottom here. So if you didn't update that column, you'd have what was previously the far left column all down here, except that the very top character would actually now be appearing at the bottom, and it progresses like that as we go through each frame. Yeah, so that's all well and good. And so my first attempt at this, I got the rocket raid problem. I got the screen scrolling by really quickly because it was scrolling in 4 pixel increments at 50 frames a second. So my first thought was, okay, well maybe I can just display it at 25 frames a second. So I did, but then it looked really jerky, and I was not really very happy with that at all. And and you know, with programming, at least I've found on the Beeb in assembly, you can kind of paint yourself into a corner. I'd made quite a bit of commitment code-wise to this, and Tricky was talking to him one day. And he said, "Well, what you could do is you could double buffer, so you could have two lots of screen memory and alternate between them." And I went, "Oh, I'll give that a go." So I did, and sometime later I got something working. So I'll just explain what that is. So the idea with having a double buffer, the limit to be aware of is that, like I say, hardware scrolling in a mode 1 screen, I'm limited to scrolling in 4 pixel increments. And as I say, that makes things run fast. So by having a double buffer screen, I could have one screen with the original sprite or tile that I'm going to display, and then in the next frame, I could then just shift that by 2 pixels along. So that if I then illustrate that here, sort of 1 frame at a time. So if we take the first frame, I display screen buffer 1, but meanwhile in the background I'm plotting screen buffer 2, but not displaying it. Then on the next frame, I display screen buffer 2, which for all intents and purposes looks the same as 1, but offset to the left by 2 pixels. So I've not done any hardware scrolling at this point, but I've got 2 screens, and one's 2 pixels to the left of the other. And then on the third frame, well, now we're back on screen buffer 1, and I do a hardware scroll, which is actually in reality moved by 4 pixels, but in comparison to the previous frame, it's offset by 2 pixels. So essentially I've halved the rate of the screen scrolling, and I've got a much more playable game. Now the trade-off for this is memory, basically, and so this is where the game became a master 128 only game, because each screen, so I use a 16K 256 by 256 pixel screen, which is mode 1 based. So 2 lots of 16K. Well, I'm not going to fit that into Beeb's main memory. However, the master has its shadow RAM, so I can display. I can have this double buffered screen feature. So I'm afraid from that point it became master 128 only. And with that in mind, I'm also able to take advantage of the extra RAM anyway, that the sideways RAM that the master has. So that's scrolling. So that took me quite a while to solve, and I'm running out of time already, so I won't go into more detail on that. So I've got stuff to be displaying on the screen at this point, and it was scrolling nicely. And then I fancied a bit of a sidetrack. I wanted some graphics that looked really nice, and we got on the forums a really nice chap by the name of John, who has not only written his own adventure game that I think it's called The Darkness of Ravenwood. He's also done graphics for a number of us games programmers on the Beeb, on the Startup forum. So I wanted some nice graphics, but how's I going to get them? So I wanted to make that easy for John. So I asked John if he would do the graphics. He said yes, and then basically I wrote a level editor, which I shall now try and render on the screen nicely. Okay, so this was fun for me because I'd not written any graphics stuff for a modern platform before. So basically, I'd coded in Microsoft C# before now, but only sort of command line console-based applications for sort of boring utilities. So here I decided to make a tile come level editor. I was quite pleased with it. It's not perfect. It's a little bit slow, but it's good enough. And it's object oriented, so things can nicely dynamically update on the screen. So to demonstrate that, if I was to select, well, I could just select the blank character here. So if I paint on here and I click something here, all the tiles that were blank on this level page have now been updated per this thing here. So yeah, it took me a while to learn coding graphics app in Microsoft C#. Got that done. So I've got a level come tile editor for an audience of one, which is John, our resident awesome graphic artist, and he went and did a bunch of level data for me, which I'm immensely grateful for. I just thought I'd show you some of the other sprites other than all the yellow stuff that people have seen at Abugs over the last couple of years. So there was my level editor. Okay, so after the level editor, so now I had some nice graphics on screen. It was scrolling away nicely. My next challenge was to do some collision detection, and so I showed you this stuff earlier, where we got memory addresses shifting in at least relative to where they are on screen every frame, and I found that a bit mind-blowing in terms of, okay, well, how the hell am I going to keep track of where everything is to do collision detection? And I'm sure I could have, I'm mused now as to whether I could have approached it differently than how I've ended up doing it. But the way I chose to do it was basically to have what I call a collision map. And I can show you an early cut of this, or a visual representation of it. So this is an early cut and it's buggy as hell, but all this is doing is actually printing it. So I keep, as the game updates, I keep a rolling update of a map representation of the screen. And so what you're seeing now is me, I can't remember whether that was in BASIC or not, but that's literally just printing out the contents of memory of that map. And the idea is that in the map, I mean, we've just seen some characters here, but actually in the map as it stands today, each memory address holds holds an ID which corresponds to a graphics tile or a part of a sprite, so I can identify what it is. The map holds where the worm is on within the map, and if it's overlapping any of the other IDs, and from that I can do a quick check and say, hey, it's collided with such and such an object, and then decide how much energy to detract, to deplete or add to the game. And I can also quickly then work out what screen address that tile is at, and then remove it from screen if it needs to. So that was quite the challenge to get going, and I sort of keep it updated in lockstep with the game. So as the game's painting that far right of the screen, every frame, the map is being updated in lockstep with it. And so that brings me on to the other challenge I'm going to cover here today, which is getting the energy bar to display on the screen, which doesn't sound like much, but was for the games coders here, they'll know what I'm on about when it comes to the fun of basically changing screen address to display at as you progress down the screen. So essentially, you had to do a bunch of interrupt requests, and you had to obviously make sure that they fire at the right time, so that things change. The reason I needed, so I wanted to display an energy bar. The reason I needed to change the area of memory at which the screen is being displayed is because, of course, what you saw earlier, most of the screen is scrolling by, but I don't want the energy bar to scroll by at all. So this kind of overlays the bottom two rows of the screen, but it's it's quite fun working out fun being a not necessarily being an accurate word for me at times for this one. So you got to fire the interrupt at the right time, like I say, but the way you do it is kind of counterintuitive. So I'll just briefly take you from top to bottom. So I've got 3 interrupts. So if we start at the top of the screen, well, the timer is now counting down to when interrupt 1 is going to fire. So literally at the point that interrupt 0 has fired, the timer is counting down to 1. However, at that point of interrupt not firing, I now have to say, well, the next time the timer starts counting down, it must be counting down to interrupt 2, which is actually the next along but 1 along. So that's kind of a bit of a that plays your head a bit whilst you're coding this sort of thing up. And then at the point this interrupt fires, I say, well, change the memory address from which to start rendering the display. So when interrupt 1 fires. So interrupt 1 fires, it changes memory address, and it blacks out the contents of memory there where the energy bar is. I tell it to display just 2 character rows worth. At that point, at interrupt 1 firing, I change the palette. Then I'm setting next time. So remember, it's the next interrupt but 1. I'm saying, well, the next time after this that the timer runs, set the counter to countdown to interrupt 0 firing. Then at character row 32, we get you get the idea. So now counting down, we're now counting down to interrupt 0. So we're wrapping back around to the top, but I'm having to set the timer to start counting subsequently to interrupt 1, and we go round and round in a loop like that. That took quite a while to for me to figure out. The hardware, the Beeb isn't very helpful in you tracking down any bugs you've got. Basically, the screen just completely corrupts, and it took a lot of stepping through code. And if it wasn't for the amazing emulators that we've got out there these days, I doubt that I would have been able to debug this. But with the help of emulation, I got to the bottom of it, and I've now got the energy bar displaying as it should. And so, yeah, as it stands, this game, I like to say it's about 80% complete. So I've got the basic functionality working for a game. The challenge now, well, barring, so the challenge now is to basically turn it into a game that anyone would actually want to play. There's still a lot to go on that front, but functionality-wise, I think it's about 80% there. I've got some sound capability to do for like music and effects, but thereafter it's a matter of making this into a game rather than more or less what it is at the moment, which is a tech demo. But I'm very proud of where it's currently at with this double buffered screen. When you see the scrolling on a proper CRT monitor, perhaps I'm blowing my own trumpet, but it's the smoothest scrolling that I've seen on a BBC Micro. So you know, I'm very pleased with that. So there we are. That brings me to the end of my talk, and I suppose at this point I'll say, are there any questions?
I guess a quick comment on your status bar. I guess it might have more things on it by the time you finish the game. Otherwise, you could probably just have scrolled the status bar by redrawing the ends of the red bit.
Don't tell me there's an easier way after all that.
Congratulations on getting vertical rupture to work, because it takes me days every time I do it.
Yeah, it took me days too.
But using working code, it still takes days.
But yeah, I plan to have a score on there as well, eventually.
Yeah, that's cool. That's very cool.
So the question is, Jason, when is it going to be ready now?
Oh, probably. Well, at this rate, probably another 5 years. But hopefully, hopefully somewhat sooner than that. I think I said this morning that I've got some annual leave booked off for later this year, and if things continue as they are, I probably won't be going very far. So the plan is to spend a good chunk of time, you know, progressing this, because you know, with my other hobby on the go as well, I really struggle to get the time to progress this.
Are you going to port it to ARM when you finish for an Archimedes?
Was that port it to ARM? Not a chance. One target platform's more than enough.
You are still enjoying yourself. That's the important point, right?
Yeah, mostly. I guess where I've got to now is that basically, because you know, it might be 3 or 6 months. You know, there'll be chunks of time of 3 or 6 months where I don't touch it at all. I do help myself slightly in that I document. You know, it's all assembler based, so I document the hell out of it. You know, lots and lots of comments, which helps me when I revisit it when I've forgotten what I've done. But yeah, the thing I find is that now it's been over elapsed time. I've not spent 4.5 years of actual time working on it, but it has, you know, it has been stretched out over 4.5 years, and it'd be nice to move on to another project. But I kind of want to finish it now because I'm so far in. So there's times when I go, you know, but I do want to finish it.
Do you know what you actually want to do in order to finish it? Do you have a plan of how the game's actually going to fill out?
Good point. So I know that I want, crudely, I want 4 levels, because my plan was literally a bank of sideways RAM per level with the master. I've got graphics more or less for 3 of those levels. I pretty much forced John to stop. I said, no, don't put any more time into this, because it's taken me that long to actually get anything done. But yeah, so I've got a broad plan. I tend to work out the details as I go along. But yeah, broadly, I've got an idea how the game's to go, and to get it finished, I've reduced the scope. I wanted originally animated enemies, you know, flying all over the place, but you know, it's taken so long to do it this far. I think I'm going to compromise, and this will be essentially collecting and avoiding static objects, which it might make for a less fun game, but it will also make for hopefully a completed game as well.
It actually scrolls the same speed as Scramble, by the way.
I thought yours was per pixel.
It Scrambles 2, because that's what the arcade is. Well, 2 mode 1, so 1 mode 2, because that's what the arcade is. The R-Type kind of level demo I put together is 1 pixel, mode 1.
Right.
But
Yeah.
The arcade's 2, so it's 2.
But yours runs on a beeb, and mine runs on Master 128 only. But this is where I was saying earlier, that the trade-off. So, I mean, Tricky, you can say more on that. But you know, with software-based scrolling, you know, you're having to update bits of the screen every frame, and the trade-off there is perhaps you can't have as much detail on the screen, because otherwise, you know, you might not get enough time per frame to update it.
Yeah, certainly you couldn't do it with all the graphics you've got on your screen. The nice thing about Scramble is there's a lot of solid color, so you only need to draw the leading and the trailing edge. And basically, I got fed up with wrapping where the screen wrapped around top and bottom and then left and right within a sprite and all that messing around. So I was like, I'm going to do a game where the memory stays still. Because well,
Yeah,
as your little PowerPoint demonstrated, it's a pain in the butt.
it really is, and yeah, I'm not eager to make my next game a hardware scrolling game.
Next game.
Say again?
Your next game.
Mm.
Busted. Have you used any sort of like compression on the sprites yet? Anything like that?
Quite honestly, no, because so far I haven't needed to. I might have that. I might have that hurdle to
Cross that
cross
bridge.
later. But yeah.
Okay, we're only 10 minutes away now from the next talk. So I think one last point I'd make, Jason, is I know a previous one of these, I think at the first midweek virtual Abug, you asked for some input, didn't you, on how to make it, turn it into a game, because you're a bit concerned you wanted it to be more than just a tech demo. I've had a look on Stardock. There's no forum for Tequila Worm at the moment. Is it worth creating a new thread for the game and possibly posting that link in the chat later on, and then anyone with some ideas can add to the thread?
Yeah, sounds like a plan. Yeah, that's something I can do, and yeah, I'd welcome input if within reason, as in not suggesting like my wife's like make it a 3D game and so but ideas of a sort of 8-bit possible nature to make it a bit more fun would be
Super
good.
Tequila Worm 3D.
Yeah.
64.
Yes.
Jason, I noticed this morning Humble Bundle are doing a game dev thing. I think it's mostly just tutorials and things, but for £1, they've got a Go.1 as part of the tutorial
Right.
to get for £1. I don't know if that's interesting or not.
It's good to know, because I am interested in that, taking a look at that.
I'm sure there's plenty of stuff online for it, but I just happened to notice that this morning. So.
Yeah, Godot looks appealing to me because it looks to be more sort of programmer centric than Unity.